Okay, for this demonstration, we're going to be looking at different colors transition metal ion solutions are. We have from left to right cobalt-2 nitrate, which is a red color, iron 3 chloride, which is a yellowy orange color, potassium permanganate, which is a really deep purple color, nickel 2 chloride, which is a green color, copper 2 sulfate, which is a blue color. Now this right here is a little bit counterintuitive. Let's take this solution here that's in blue. It isn't blue because it's actually absorbing blue. The reason why it actually looks blue to us is because it's actually absorbing the opposite color, the complementary color to blue, which is actually a red color. We've learned in our course here when ligands, in this case here water, try to surround the central metal ion, they cause all the d shells to go up in energy, splitting into two levels. Because the size of the energy gap corresponds in the visible region here, there's one unique wavelength that gets absorbed. Whatever isn't absorbed here is then transmitted through the solution. Right now here I just have the classroom white light here shining on these solutions here. We're seeing all the vibrant colors here. Just to demonstrate this for you here, I have a laser pointer. My laser pointer here is going to send off a red wavelength, so roughly about 656 nanometers. Red is the complementary color to blue. So as I put it in here, just to verify for us here, how do we know that this is blue? Not because it's absorbing blue, but it's because it's letting out blue. I'm going to shine my laser pointer here through the clear of the glass here, just so that you can see that part there goes through no problem. As I then lower the laser pointer here, you notice definitely this laser pointer here has trouble getting through the copper 2 sulfate solution. Okay. Let's compare it against a few other transition metal ion solutions. So green is also across from a red wavelength as well. We're going to see whether this gets absorbed. You have to look at exactly sort of what wavelength this red is sending in. So it's getting through the glass, no problem. As I go through the green, it is getting through ever so slightly here. We're going to find that depending on the concentration of the solution, that can also have an impact on how much red is actually absorbed. We can compare that to, let's say, purple. This purple potassium permanganate is really concentrated here. I would doubt that this laser pointer can get through the glass no problem here, but as it goes through the really high concentration, it really is having trouble getting through. I can compare that similarly here to a yellow transition metal ion solution here. This is going through the glass. It's able to get through the yellow no problem. Okay. And then just to verify for ourselves here, the reason why this cobalt-2 nitrate solution looks red is not because it absorbs red. If I have a red laser pointer, if I don't absorb red, I would expect this to go through. Let's have a look. So we have a laser pointer going through the glass here. As I go through the solution, again, no problem going through that red solution. Okay. So hopefully that helps give you a visual feel of this whole notion of one color being absorbed and then reflecting or transmitting the complementary color. If you have any questions, let me know. Thanks, guys.